All right, let's go ahead and get started on the video answer key. So we did question number 1 in both classes. So what we talked about is that when we looked at a pattern from left to right to see if it was arithmetic, we noticed that it wasn't going up or down by the same amount. And then when we looked for geometric going from right to left, there wasn't a common ratio. So what we did again is we just took the term numbers and put them above and figured out that the pattern through some trial and error is x squared, the term number squared, plus adding the term number again. Even without doing that, we can figure out that the next term was 30, and then when we put 15 into our x, we ended up getting the 15th term to be 240. So I'm not going to talk about this one anymore because we did do that again in both classes. All right, number 2, the first thing I'm going to notice in my pattern is that even though I see a 4 that's the same as 12 over 3, and that my denominator is consistently 3. So that's going to be part of my rule. As far as the next term, the numerators go 10, 11, 12, 13, so my next term is just going to be 14 over 3. But then to find the 15th term, now I'm going to try to establish a pattern. So in my numerator, as I go from left to right, I notice that it's always going up by 1. So that's going to be my D. And then what I can do is go to the formulas, which you should have in front of you for now, but they will be given to you. And the formula I'm going to use is for my arithmetic one that just says take the first term plus your constant with n minus 1. So that's what I'm going to do on problem number 2. So ignoring the 3 in the denominator, because it's always going to be 3, I take my first term, which is 10, plus d, which is 1, and then n minus 1. I'm going to distribute the 1, and when I clean it up, I get n plus 9 as my rule, and I'm going to add that to my numerator. Now that I know my rule, I can take the 15th term, put 15 in for n, and I end up getting 24 over 3, which is the same as 8. All right, let's go to the next one. The next one is geometric. I know that because I see the R. So I'm just going to put that into the basic formula. Again, you should have that. It's going to be this formula. That's my basic geometric rule formula. So I will take the first term, which they give me is 10. And then I take R, which is a half. On the printable answer key, I used a fraction. And then to the n minus 1 power. Now that I have my rule, I can take the fifth term, put it in there. So if I do that, it ends up being 10 times a half to the fourth power. And you can either write down the decimal answer, or if you want your calculator to turn it back into a fraction for you, you'll get 5/8. All right, let's go to number 4. So on number 4, what I notice, so again, the first thing I'm going to check is left to right. Going left to right, it's not going up consistently or down consistently by the same amount. So the next thing I'm going to check is going from right to left. And as I start checking, this ratio, so I might take 0.055 and divide it by 0.55, or 5.55 and divide it by 55, I get a consistent ratio, and that ratio ends up being 0.10. Or you could write it as 1/10 as you want. I'm just going to make this simpler and keep it as 0.10. So I'm able to write my rule because this is geometric. And the rule goes, I take the first term, which is 55, times, and I'm going to use the times just because of the decimal, my r to the n minus 1. Now on the printable answer key, I wrote it a little bit differently, but I still get the same thing. So now what I'm going to do is the next term I could figure out anyway. I just add one more 0 in my list. But as far as the 15th term goes, when I put this in the calculator, it comes up in scientific notation. I believe the calculator gives you this. You could also write it as 55 if you wanted, times 10 to the negative 14th. Either way, same thing. All right, let's go to number 5. So the first thing, again, I'm going to check. Going left to right, I'm not going up or down by the same amount because it goes positive, negative, positive, negative. So this time I'm going to go from the right to the left, and as I take negative 324 divided by 108, or 108 divided by negative 36, or whatever the trend is going to be, I do get a consistent r, and that r is -3. So I can go ahead and write the rule for my geometric series rule, and it says take the first term, which is -4, times r, which is -3, to the n minus 1 pattern. And again, even if I don't see the pattern, I can probably guess the next number because just looking left to right, I'm always just timesing by 3. So if I just keep that pattern up going left to right, then my next number is 972. I'm sorry, I'm timesing by -3, so I get positive 972. And then the 15th term, I'm actually going to write down here because it's a little too big. So I take -4, in parentheses -3. 15 minus 1 as an exponent would be to the 14th power, and I get -19,131,876. So that's my 15th term. Number 6. Number 6 is also geometric because even though the first one isn't a fraction, I can make it into a fraction. Now what consistently stays the same is my numerator. So for the numerator, it's always going to be 5. When I look at the denominator, again, going left to right, 1 to 2, 2 to 4, 4 to 8, it's not going up or down by the same amount. So as I go the other way from right to left, I notice when I take 16 over 8, or 8 over 4, or 4 over 2, I always get an r to be 2. So that's going to make it geometric. So as far as this goes, when I look at my first term, the first term is 1, which you don't even need to put on there, and then r to the n minus 1 power. What's the next term going to be? Well, even without figuring out the rule, I know my numerator is going to be 5, and I'll just take 16 times 2 to get 32. What's the 15th term? Well, I just use my formula. I know it's going to be 5 in the numerator, so I'm just going to focus on the denominator, and if I put 15 in there, I'll be taking 2 to the 14th power, which is, if you go to the answer, 16,384. So that's number 6. The whole row is geometric. All right, the next row is all arithmetic. I know this on 7 because they give me D, and that's arithmetic. And then for 8 and 9, I told you in class, I want you to base these as arithmetic. So to write an arithmetic rule, I need the first term, which they give me. I also need D, which they give me, and I'm just going to put the information to the formula. So I take the first term plus D with n minus 1 and clean it out. And when I'm done, I get my rule, 10n minus 9. As far as the 15th term goes, well, I'll just put 15 in. And when I'm done, I get 141. All right, the next rule. On the next rule, I don't know the first term, but I do know the 10th term, so I'm still going to use the formula. And I know that the 10th term, which is -1, comes from taking the first term plus d, which is -1, and then n minus, I'm sorry, I wrote d wrong. D is -4/3 with n minus 1, which, sorry, I'm making all these mistakes, n minus 1, 10 minus 1. So I'm going to clean this up a little bit. I'm going to turn my parentheses into 9. And then when I take my -4/3 times 9, I just get -12. So when I'm done, I can figure out that my first term was worth 11. And I'm going to go back to the original formula that says to get any term, I take the first term, which we now know is 11, and then plus n, which they give us as -4/3 with n minus 1. So I'm just going to distribute the -4/3. And then I'm going to let my calculator do the adding of 11 and 4/3. And when I'm done, as far as my formula goes, I'm going to write it the simplest way. And it is -4n plus 37 over 3. That's going to be the easiest to work with when I find any term. And then when I put 15 in, I end up getting -23 over 3. And that's number 8. All right, going to number 9. On number 9, they give me two different terms and their term numbers. So this is the one where we decided to use a system of equations. So I know that I got 3,362 by taking the first term plus and d, which I don't know, and then n minus 1. So since n is 18, 18 minus 1 is 17, I'll have 17d. And then I got 7,362 again by taking the first term plus d times n minus 1, and since n is 38, 38 minus 1 is 37d. So rather than change the signs and add them, I'm just going to subtract. So when I subtract the thousands numbers, I get 4,000. My a's go away, and when I subtract the d's, I get 20d. So when I'm done, d is worth 200. Now that I know d, what I can do is go back and put it into one of my equations. And I'm going to put it into the smaller of the two equations. So I'm going to be putting 200 into that d right there. So I'll take 3,362 equals my first term. And then 17 minus 200 is 3,400. And then when I subtract to get a by itself, I get my first term to be negative 38. So now that I have the two things that I need, I'm ready to write my equation. So I'm going to do a little bit of erasing from the other problem so I have room. So now to write my final equation, to get any term, I take the first term, which is now worth negative 38, plus d with n minus 1. So I'm going to distribute the 200 and combine my like terms. And so when I'm done to find any term, it's 200n minus 238. So there's my rule. And then I can't forget, I still need to find the 15th term. So I'm going to put a 15 into this n. So I'll be taking 200 times 15 minus 238. And when I'm done with that, my final answer is 2,762. All right, let's go to the bottom row. So we'll probably have to finish the bottom row on the next video, but that's okay. So on 10, it's geometric. I know that because I have an r. And the rule says to find any rule, I need the first term, which I don't have. But I do have r, so I'm going to use the fact that I have the fourth term. So the fourth term of 25 was taken by the first term times r to the n minus 1. And since n is 4, 4 minus 1, I'll have 3. So, whoops, and I should replace r. I do know r. R is negative 5. So to clean this up, I'm going to go ahead and take negative 5 to the third power, and I get 125. And when I divide, I get my first term, which as a simplified fraction is negative 1/5. Now I can go back and write my rule. The rule is I take my first term, negative 1/5, times r, which is negative 5, to the n minus 1. And then to find the 8th term, what I need to do is just put 8 in there. So when I do that, I'll have negative 1/5 times negative 5 to the 8 minus 1, so 7th power. And I get 15,625 as my 8th term. Okay, I'm going to go ahead and stop there for the first video segment, and I'm going to pick up 11 and 12 in the second segment.